Hi all, my name is Mads Barnkop from Kaizer Power Electronics. Today we are going to tear down this little ESAB Caddy 1500, which is a TIG welder, and unfortunately it is defective. I do not own a TIG welder myself, so I would have liked to repair this, but as we can also see on the toe tag here, it says at startup it smoked from the machine. Tried to repair it, changed fuses, it smoked again. So I think it's safe to say that having let out the smoke twice, this is not a unit that I would like to spend my time on, considering how little money you have to spend on buying a new one. So let's take it apart. At first we could take a little look at the unit itself. Quite small form factor, but it is also only a 110 to 115 or 150 amp TIG welder. The sticker is rather smeared with oil and dirt here, but we can say at 100% it would run 110 amps, and at 25% duty cycle it could run 150 amps. It also has adjustable waveform and timing here at the front. You can weld with either DC or square wave. There's also something with automatic starter and arc starter and such. And you have the connectors for the plus and minus, your controls, gas. Well, that's probably gas out, as we have on the back side here. We have the gas input, mains input, and a on-off switch and a fan grill. You can see this side also. It's coming off. So let's see what's inside. Small welders like this are quite compact, as you can see. There is electronics going everywhere. But if we try to take a look at the mains input that we have at the back side here, we have a filtering board up here with a low voltage power supply that goes over to the control board. Now this flat cable connects up to the display and buttons. Then there is a shielded cable going out to the welding handle. Let's swivel a little screw there. We can see this is all varnished, as this is to be used in a dusty environment where you have metal dust in the air, so you don't want your circuit boards short circuiting out from that. So these are all plastered in varnish or lacquer, or what you call it. So this is the power supply connection. Here at the front we can also see we have a small choke on the push button input here. And we have the gas hose just running straight through the unit. The in and output terminals sit of course to the large connectors that we can see later on. See, these just clicks out quite easy. So these are probably made to be serviced, but even the cost of just getting a spare board like this is a good reason why it's not going to happen, because if that doesn't work you have to change the next one and so on, and you could just have bought a whole new unit. So over here we have the filtered mains going down on the power section board. So let's look at that next. It's quite clear that we have a three-phased IGBT brick sitting in here. That was glued over to avoid any short circuits on that. There's no apparent failed components here. It's a little resistor that looks like it has been hot, but nothing obviously black. I would have to mention, of course, that I did try to power this up and it doesn't work. Nothing happens, and it doesn't even blow the fuses anymore, so it is not doing anything. Now on the other side here we have the output choke, but this is also interesting. That's a little pulse generator. This is actually the starter arc generator, so that generates a 500 volt DC pulse, enough to strike a arc and start the low voltage high current arc. You see that just sits with a single turn around the output choke here, so that's enough to actually generate a high voltage to initiate that. Let's just get these off. So we can get to the other side and get the power section taken apart. So away with that. Now the little power supply here, we don't need that anymore either. Not much special to say about that. It's sectioned up in a low voltage and high voltage part. Not quite with the normal isolation that you would see. Maybe a cut track in the board. But if it's all floating and being a high voltage unit, that doesn't really make much difference then. It's just there. Soon we can also see the whole core here, which is the heatsink. Okay, that's a lot of dust in here. Nice. Okay, so here we can actually see the part number. That's a ESAB branded IGBT, so they run their own or get theirs made OEM from a brand name manufacturer of IGBTs. And over here we have some output diode modules. But yeah, let's get some more screws removed from the power section here, so we can get underneath and see all the silicon. So the main IGBT driver that we have here. Seems like we have isolated power supplies, and this gate drive transformer goes down to the output SCR here, and we have gate drive transformers for the IGBT brick sitting here. So as we can see, it's just a large three-phase brick. It says here, just an ESAB number, but maybe here we have it DP35L600. So this is a 600 volt module rated at 35 amps. And it says here in the solder label. Okay, that works fine. Over here we can see where the DC bus filtering capacitor connected to. So that just comes up, yeah. Okay, that's dirty as hell. That's sitting right at the fan as well, because this is probably a bit underrated current wires, and you just cool it a lot instead. But 1000 microfarads at 450 volt AC or DC. The black box we have sitting here, that is a choke. So we can try to take that out as well. As you can see, just a little regular iron core choke. Now that connects the output. It has its own DC bus choke, IGBT module. Output from this drives into a isolation transformer. And that's pretty important for a welder, that you isolate your output from the mains, as you have a low voltage source that you can actually touch as you touch the metal that you weld on. You don't want to get killed from a badly isolated or non-isolated welder. That's just stupid. I have to remember to use this. Now here we can see the output transformer. Seems to be same gauge. Well, that's actually doubled, so maybe it's actually a step-down transformer as well. But that has a high isolation class, as it is used to isolate the two sides of it. We have a little thermal switch sitting here on the heatsink. Let's take a look at this module here. Okay, that was a little ferrite ring choke sitting around a holder here, so maybe that's a ground path. That's funny to filter out some noise that way. So what we have here? Okay, it's a double diode module, so that's just a output module. 2 diodes in one package. And out here we have a output choke, it seems. Encapsulated, just says it's from 310103, so from 2003. I didn't really find any date stamps on the unit. So that is the last output choke that we had sitting here on the last board with the diode modules. There's a little measuring transformer, or just a little choke. Actually connects to the same. Okay, so these two wires. Okay, it has another two here. Okay, so that's just a little choke. But this is the output board. Only has a little filtering. And then on the output connector there was a current shunt. So here we have it, 200 amps. As we see, this has been adjusted by measuring the voltage drop across it when it pulls 200 amps. And you just saw a bigger and bigger slot into this until you have the voltage drop that you need. Then you have the voltage drop over this gap. So yeah, I can save this and use that for a 200 amp shunt. I guess that's just a standard, maybe 75 or 60 millivolt drop, but yeah, I actually have to measure that to be sure. So maybe it's not that useful anyway. Now let's see what is left in this package. Is just a heatsink. Heatsink and plastic. So that is what you find inside a TIG welder. I'm Mads Barnkup. Thank you for watching. Subscribe if you like it. I'll see you next time.